All right, today we're working on our circuits worksheet. We're just going to do the basic ones today. So we're going to start with 1 through 3. On this first one, when we look at it, it's a series circuit because we have one path to go through, no choices. When it's series, that means the current is the same throughout, so we can just copy this 2 all the way through. Once we know that, we know B equals IR, so we can just multiply 8 times 2 to get 16, 6 times 2 to get 12, 4 times 2 to get 8. And now we know our rules for a series. We just add up the resistors. 8 plus 6 plus 4 is 18. And then we can do 2 times 18 and get 36. We also know that if we add the voltages, we should get the total voltage. So if we add these 3 together, we also get 36. So that's a good check to make sure we're doing it right. On number 2, as we go through, we have a choice. No matter which way we go, we've got this choice. We can go around to resistor 2 or stay in resistor 1. If it's got choices, it's parallel. If it's parallel, that means the voltages are the same. So we can copy these down. And now we have 2 out of the 3 because V equals IR. I is equal to V over R. So now we can just take 12 divided by 2 and get 6. 12 divided by 4 and get 3. And now we can add up our resistors. When we add resistors, they're in parallel. Parallel resistors add up a little bit differently. Right? We have to do the 1 overs. So 1 over the total resistance equals 1 over resistor 1 plus 1 over resistor 2. Okay, we really need to write this for resistor total. So that's 1 over resistor 1 plus 1 over resistor 2. And I like to write this using more of a exponent fashion. So we're going to say resistor total. Instead of resistor 1 to the negative 1 is the same as 1 over resistor 1. Okay, and then we're going to have resistor 2 to the negative 1, and then this 1 over everything is this guy out here. And now we just put our numbers in. So it's 2 to the negative 1 plus 4 to the negative 1, all that to the negative 1. And when we put that in the calculator, we end up with 1.3333 on and on and on ohms. Okay, now we can use our 12 divided by 1.33, and we end up with 9. We could also, if we looked at our rules, 6 plus 3, all the currents must add up to the total current. So 6 plus 3 is 9, so again, it's another check. Okay, if we look at number 3, on number 3, again, it's parallel because we have choices on which resistor to go to, but we don't have any voltage, so we can't solve that. So we have to look at what do we have. Well, we have 2 out of the 3 on this third row. So 12 times 3, V equals IR, is 36. So we know we have 36 volts in resistor 2. Because they're parallel, the voltage is the same everywhere. So it's 36 volts all the way down. And now again, I can solve for R, because R is equal to V over I, because V equals IR. And so 36 divided by 1 is 36, right? The 36 divided by 3 was the 12. The 36 divided by 2 is the 18. Okay, now we got 2 choices. We can add these in parallel. So resistor total is going to be 18 to the negative 1 plus 12 to the negative 1 plus 36 to the negative 1, all to the negative 1. And we can also add up these and then go across. So 1 plus 3 plus 2, we're going to get 6, right? Because all the currents have to equal the total. And then we could do 36 divided by 6 and get 6. Let's do this down here and see if we actually get 6. Let's check our answer. Okay, so we have 18 to the negative 1 plus 12 to the negative 1 plus 36 to the negative 1, quantity to the negative 1, and boom, we ended up with 6, just like we said we should. All right, now we're going to jump up to 9 through 12, skip some of those combination circuits. We'll come back to those on another video. So we're just going to use Ohm's law. Ohm's law says V equals IR. We're going to calculate these unknown quantities. So on this one, we have resistance and voltage. We're looking for current. So current is equal to voltage divided by resistance. So in this case, my voltage is 3.5 volts. My resistance is 470 ohms. And so when we do that, we get 3.5 divided by 470. And we have 0.00744, some crazy little tiny number. Okay, it goes on and on. We have to stop at some point. But this is where a lot of times we use milliamps because this is in amps. So if we move our decimal 1, 2, 3, we're going to get milliamps. So we get 7.45 milliamps. And that's kind of a better way to write it, although this is also correct. Okay, on this next one, we're looking for resistance. Resistance is voltage over current. We have the voltage and the current. Another thing we got to worry about is this is a micro. Micro is 10 to the negative 6. That means there's a million microamps in 1 amp. So we got to move this thing 6 places. So this is going to be equal to 0.0134155 amps. And we've got to have it in amps before we can do this equation. Okay, so we're going to take our voltage of 3.5 volts. We're going to take our current of 0.0000155 amps. So 3.5 divided by, and we get a great big monstrous resistance, 225,806. And we could leave it like that. A lot of times they'll convert it. You notice they put K's up here, so we have 225.8 kilo ohms. So this is correct. Sometimes this is a better way to write it. Okay, on the next one, now we're looking at voltage. So V equals IR. Okay, my resistance is in K, so we've got to convert this. So my R is equal to 22,000 ohms, because since K means 1,000, we move it 3 places to the right. This is in millis, we got to go 3 places to the left, so my current is 0.0014 amps. And now I can put that in there, just multiplying the 0.0014 times the 22,000 ohms. 22,000 times 0.0014. We do that, we get 30.8 volts. Okay, and that one's good, just like he is. All right, now for the next one, we want to calculate the total resistance. So in series, they just go together. So for this first one, RT for this first one is just equal to R1 plus R2 plus R3, which is 150 ohms, plus, remember this is in K, so we have to move it 3 places to the right. So 1200 ohms plus 820 ohms. So for the first one, it's 150 plus 1200 plus 820, and we get 2170, 2170 ohms for the series. For parallel, for the second one, resistance total is equal to the 1 overs. So we're going to have, again, it's K, so we've got to move that over. So 5600 to the negative 1 plus 680 to the negative 1 plus the 8,200 to the negative 1, again, because it's got the K, meaning 1,000, and then entire quantity to the negative 1. Can't see that very well, sorry. And then we just type it in our calculator in parentheses, 5600 negative 1 plus 6800 negative 1 plus 8200 to the negative 1, quantity to the negative 1, and you can see we get 348.5, so just go 349 ohms. Now you want to notice something over here. The resistance is bigger than the biggest one, right? It's bigger than 1200. When you do parallel, this is always smaller than the smallest one. The smaller was 680, right? It's always smaller than the smallest. All right, this one here, I think it helps to make this table. So we're going to do voltage, current, and resistance, just like we did on 1 through 3. We're going to need to know the things for the battery. We need to know for resistor 1, resistor 2, and resistor 3. So we want to know the voltage, current, and resistance at every spot. Well, they told us the voltage was 9 volts. They didn't tell us anything about current anywhere. And they told us the resistance at resistor 1 was 470. Right, correctly. Remember, these are ohms, these are amps, and these are volts. Okay, the next one is, again, this K, so we got to multiply by 1,000, so it's going to be 1,200. And this one is 270. From here, the only place I have anything, right, because the current is the same in a series, so I don't know anything there. Can't fill that out. Voltage, we don't know anything. I got 3 out of the 4 on resistance, so I can just add those together, right? Resistance total is just these resistors all added together. So if I take 470 plus 1200 plus 270. I get 1940 ohms. And now I have V equals IR. So I is V over R, which is going to be my 9 volts divided by my 1940 ohms. 9 divided by the 1940. And I get 0.00464. 0.00464. This is a lot of times where we go to milliamps, right? It'd be 4.64 milliamps, which would make it just looks better or make more sense, I guess. But because we're going to have to always use amps when we use this other stuff, I'm going to leave it in amps so I don't have to keep converting back and forth. And now we know in a series circuit, current is the same throughout. And now we just multiply across. So 470 times the 0.00464, and we get 2.18. And then we have 1200 times 0.00464, we get 5.57. And then we have 270 times the 0.00464, and we get 1.25. And if we added these three together, we should get pretty close to 9 volts. Remember, we rounded off all these numbers, right? We rounded off the 0.464, we rounded off these three things. But let's try it. Let's see what we get. 0.218, or 2.18, sorry, plus 5.57, plus 1.25. Oh, and it worked out perfectly. We got 9. Okay, so that was our check. But sometimes you'll get 8.99 or 9.01 because of the rounding. Okay, so don't stress if it's off by just a tiny bit. Just know that you rounded things. Now we got number 12. We're doing the exact same thing. So again, I'm just going to make my table because I think it helps, especially when you first start. Make the table. It lets you see the stuff coming up. So we got voltage, current, and resistance. Again, we're going to know for our battery. And then we have, again, 3 resistors. So resistor 1, resistor 2, and resistor 3. And so our battery this time is 12 volts. I'm just going to put the volts, the amps, and the ohms up here so I don't have to write them every time. I can just see the numbers. Okay, and that was, what, 8.2? So it's kind of tiny. Let's zoom in a little bit, see if we can see this better. Yes, I believe that's 8.2. That's what we're going to put anyway. So, but it's kilo, so that's 8,200. So we have to multiply by 1,000. This is 6.8, I think. Whew. My old eyeballs can barely see those things. So I think that's 6,800. And this one, I believe, is 4.7. Okay, so 4,700. Okay. Now again, we have to start just like we did the last one. And this is how we start a lot of things, because on most circuits, you know the resistor values, you know the battery value. It's everything else you have to solve for. And that's exactly what we're doing here. And so when we add up resistance in parallel, it's just the 8,200, resistor 1 to the negative 1, plus resistor 2 to the negative 1, plus resistor 3 to the negative 1, quantity to the negative 1. So let's put all that in our calculator here. So we have 8,200 plus 6,800 plus 4,700, all quantity to the negative 1, and we get 2,076. Let's just round that off. 2,076 ohms. Okay. Now again, to get current, current equals voltage divided by resistance. Okay, so we can go through this one. And this, our voltage is 12, and our resistor is 2076. So now as we do this one, 212 divided by, instead of typing all that, we'll just cheat a little bit. And we get 0.00578. Okay. And now where do we go from here? Last time we could fill out the current. We could have at the very beginning, because if you remember in a parallel circuit, the voltage is all the same. So we could have just gone 12 all the way down. And now we can solve this current all the way through. So we could have done this one a little bit differently. So we're still doing the same thing. We're still solving the current all the way through. So no matter what you do, you still have to do all these steps. Didn't really matter which exact direction I did it. So we're doing I equals V over R for each one of these. So it's just going to be 12 divided by the 8200, 12 divided by the 6800, and 12 divided by the 4700. So I'm not going to write them all down. I'm just going to do them in my calculator. So 12 divided by 8200. And then we have 12 divided by the 6800. And then 12 divided by the 4700. Okay, and if we look at those are my three. So 0.00146. Okay, 0.00146, 0.00176, and 0.00255. Now again, these three currents added together should give me this one. So let's try that. And again, you can see I rounded everything off quite a bit, so it might not be perfect. Worked last time. Let's see if it works this time. And we get 0.00577. And see, this is 578. Remember, we rounded everybody. So to be off by that tiny, tiny bit, we're still the same. So we're all good. So that one checks. Okay, and then the last one I'm going to do on this video is I'm going to jump forward to, sorry, paper flip here. Number 14 through 16 are basically just a simple circuit as well. And then we'll do the compound circuits next time. Okay, so the diagram below represents an electric circuit consisting of 4 resistors and a 12-volt battery. What is the current measured in by the ammeter shown in the diagram? Okay, well, the current here, they're looking, is through this 6 ohm battery. So now we can do the entire table and solve everything if we want, but they're just asking for a specific spot, the current through here. So look at your rules. The rules of a parallel circuit tell me that I have the 12 volts across every resistor. So that means I have 12 volts here, 12 volts there, 12 volts here, 12 volts there. So if I look at this, if I have voltage and I have resistance, I can find current. Remember, current is voltage divided by resistance. I know I have the 12 volts. I know my resistor is 6 ohms. 12 divided by 6 is just 2 amps. So I know this one has to be 2 amps. Okay, the next question says, what is the equivalent resistance of the circuit shown? The equivalent resistance is another way of saying basically total resistance, because they're asking of the entire circuit. So it's just a total resistance of the whole circuit. So remember, the total resistance or equivalent resistance is just 1 over everything. Okay, so it's going to be 6 to the negative 1, because that's the same as 1 over, plus 12 to the negative 1, plus 36 to the negative 1, plus 18 to the negative 1. But remember, we've got to do the entire quantity to the negative 1, because it was 1 over the total. So we have to do that 1 over on this side. Again, let's just plug our numbers in. So we have 6 to the negative 1, plus 12 to the negative 1, plus 36 to the negative 1, plus 18 to the negative 1. And do that entire quantity to the negative 1. And we get 3. So we have 3 ohms. And remember the little trick, you got this one here should be smaller than the smallest. 6, 12, 36, 18, it's smaller than any one of them. So it doesn't tell me exactly if I'm right, but it gives me a good idea that at least I've got a chance of being right. If this was like 9, well, it's not smaller than everybody, so we know I got it wrong. And now what is the voltage on the 36 ohm resistor? Oh, well, that one's super easy. We already answered that one because we said parallel, the voltage is the same everywhere. So the voltage on the 36 has to be 12 volts. Okay, so that's it for our simple circuits for this worksheet. I will make a second video that will go over the compound circuits.